This conference will now be recorded.
Yeah, so as we were explaining yesterday about the IPv4, the 32-bit addressing format, and why they chose, because the register available at that point of time was only this big, okay, and this was sufficient to provide 4.29 billion IP addresses, and this was very sufficient. I am talking about a few decades before. At that time, the internet was becoming popular, right? So that is the reason. Even now, there are many companies who are still happy with IPv4. So with IPv6, yes, of course, now the big companies like Geo. So if you notice in your mobile phones, the Geo is the only in India who has migrating or who is migrating to IPv6, because Jio has so many subscribers that it cannot be handled by IPv4. So that is the reason they have switched to IPv6 addressing format, which is of 128 bit, okay, which is very huge. But we are not going to be discussing on IPv6, rather we'll be discussing on IPv4, and our entire course will be based on IPv4 addressing format, right? And yesterday, so I was exploring that the computer or any device doesn't understand this value, which is in a decimal, okay. It only understands the sequence of zeros and ones, so which is called binary, right? So which will be in the binary format, and any IP addresses will consist of 4 octet: first, second, and third, and fourth. And 10.1.1.1 is represented as this, okay. So as you can see, now how do we calculate this? How we have come to the conclusion? So as it come in a random way? No. So there is a formula, okay. So as clearly mentioned here, the device only understand the binary notation, that is sequence of zeros and one. And as you can see, there is how many places? So octet means 1 2 3 4 5 6 8 places is there, right? So you need to start from the rightmost bit, okay, and you have to always start from 2 to the power 0, and 2 power 1, 2 power 3, 2 power 4, like this. Oh, so let me open an Excel and I'll explain the calculation. After this, I will guarantee that you all of you will be able to calculate the any number into its equivalent binary value, okay. So first let us, I will only showing for first 8 bits, okay. Rest everything is one and the same. So what I told you, so 1 2 3 4 5 6 7 8, right? 3 4 5 6 7, yeah, clear. So let us draw a column here. So I will start writing from 2 to the power 0. Why 2? Why 2? Because it is the value for binary is 2. So 2 power 1, 2 to the power 2, 2 to the power 3, 2 power 4, 2 to the power 5, 2 power 6, 2 to the power 7. Clear? So 2 power 0 to 2 to the power 7. So 8 places. So I will write the number here. 1, 2, 3, 4, 5, 6, 7, 8. So 8 bits. So this represent one octet. So let me write here. Okay, O C T E T. So this is an octet. This entire thing, right? From here to here. Okay, don't get confused. That let me paint here. Yeah. So this is an octet. Fine. Now what is 2 to the power 0? 2 power 0 is 1. What is 2 power 1? That is 2. What is 2 power 2? 4. Similarly, 8, 16, 32, 64, and 128. So is this clear? So the equivalent value, the 2 power 0 is 1, 2 power 1 is 2, 2 square is 4, 2 cube is 8, 2 power 4 is 16, 2 power 5 is 32, and 2 power 6 is 64, and 2 power 7 is 128. And equivalent value I have written below. Okay, until here it is clear? Yes. Now, the next concept. Okay, so now how do we convert any value? So for example, I can give any IP address. So let us pick the IP address of our computer itself. I mean my laptop. Okay, just press window key and R, type CMD and enter. Just type how to get your laptop's IP address. So you have to type IP config and enter. You will get an IP address, right? Okay, you can take anyone. Now this is the IP address assigned to your Ethernet adapter. Okay, so we'll be exploring about what is meant by Ethernet adapter and all a little later. But for now, think that this is the IP. Clear? And this is the IP address which is assigned to your Wi-Fi adapter. This is for Ethernet, so you can pick this one. Doesn't matter. Okay, so let me take this as an example. So how do we convert it into decimal? Okay, so let me paste it here. Now this is the IP we have. So take the first one, 172. So we have to put 1 in these 8 bits in such a way, if you add the equivalent digits above, I should be able to get 172. Okay, so for example, put 1 here. So 128 plus 1. So what is 128 plus 64? So 128 plus 64 is how much? 120 plus 60 is 180. So it is not matching. So you have to put 0 here. Okay. Then what is 128 plus 30? So 130, 160. Okay, that is fine. Then what is 160 plus 16? So 176. No, it is not a match. So then 160 plus 8? No. 168. How much was there? 128 plus 32. 160, 160. Yeah, 168. Fine. Okay, then 168. Then how many more we should get? 1. Sorry, 4. So 0, 0. So this is how I represent 172 in decimal. In binary. Is this clear? This calculation? See,
Can you repeat that one? I didn't get that. How you are taking as a 1010? How?
yeah, 1010 how I taking means you have to add. See, if you put 1, that is means true. If it is 0 means it is false. So this value will be taken as 0. So you have to put 1 in the 8 bits in such a way that the equivalent number, if you add, you should be able to get the 172. So for example, where and all I have put 1, just see. So I have put here. So that means 128. So let us write 120 here. Okay, then 0. Don't worry about it. 0 means this is also 0. Then 1 here. Then 32. So calculate. Okay, then 0. Leave it. Then 8. So put 8 here. Then 4. At the place of 4, I have put 1. So 4. Okay. So now what will be the sum of this? See here. The sum, can you see? In the
Yes,
down
sir. Yes,
also
sir.
it is made. So 172. Or you can calculate like this also. Right? So sum of these numbers. So 172. Okay, I will do it for all the 4 octets, then you will understand. Okay, so 172 we know. So this is how I write 172. That is 10101100. Okay, so now let us calculate for 27. You will understand. So 27 is like very low number. Then we have to put, because here also I will put 0, 0, then 32 also 0. Then from here I will start. So 1. So means 16. The equivalent value is 16. So 1. Then what is 16 plus 8? That is 24. Yeah, valid. So I'm going to write 1. Then 16 plus 24. So I need 3 more. So I will not take this. So this will be 0 and 1 and 1, because 2 and 1. So 16 plus 8 plus 2 plus 1 will be 27. Clear now? Okay, I will do for 64, then you'll understand. Okay, now 64 is already we have a value. Just put 1 here and rest everything 0. You got it?
Yes, sir.
Because already we got the value 64, because the second from the right, the second last bit, the value of this bit is 64. Okay, so I will put 1 in order to get the value 64, and the rest all the bits will be false or 0. Then I'll get 64. And 1 is very easy. This will be 1 and rest everything will be 0. Sorry, 1. Is this clear?
Yes,
So
sir.
this is how we should calculate the equivalent decimal value of equivalent binary value of a decimal number, because we will understand this format, but the computing devices will not understand this. Is it clear? Or you want me to do one more example? Okay, I'll do one more example. So I'm going to pick this one, 192.168.0.110. Okay, let us pick this and calculate. Then you'll understand. Okay, now same thing I'm going to do. So paste here. So this is our requirement. Now this is a IP address. So equivalent binary we have to calculate. Okay, and remember guys, these are equivalent for 172. If I have to write in a series, I will write somewhat like this: 10101100 dot 0001111 dot 0100000 dot 0000001. So this is a complete IP address represented in binary. Is it clear? Like this. So like this, if I write, it will be very big. Clear? Okay. So now coming back to the, so next calculation. Now, so 192. So where in what all places I should put 1 in order for me to get 192? So I'll start with here. Okay, I will start from here. So 1. Okay, so what is 128 plus 64? Here also 1. So what is 128 plus 64? 130, 192. Yes. So 192. Because what is 128 plus 64? It is 192. Okay, you can check here also. See, if you select any two cells, the equivalent sum you will get it here, right? So 192. So rest everything is 0. Okay, so rest everything is 0. Then what will be the 168? Similarly, put 1 here. Though this will be 0 because already 192 we have taken. Then what is 32? So 160, correct? Sorry, 160, and how much is left out? 8. So this will be 0 and this will be 1 and rest all 0 0. So this is the representation of 168 and this is 192. 0 is nothing, that's everything will be 0. 0 and 1 is very easy to calculate, so this is 0, that's it. So 1110, so how will you calculate 1110? So again this will be 0, this is 1. Okay, so 64 plus 32 is how much? 64, 66, 96. Yeah, 96. And how much we need? 110. So another 14, right? So another 14 means, so 16 will not be sufficient. Then 8 plus 4 plus 2. Okay, correct? So this is the representation of 110. Clear? So this is how I represent these things. Is it clear? Any doubts? See, yes. Yes, please go ahead.
No, it's clear, sir. I said yes for a clear.
Okay, okay. Okay, so now you know that how we can calculate the binary representation of a decimal number. Okay, so now, okay, now they decided IPv4 is sufficient and how they will get the 4.2 billion IP addresses. So there is a formula to calculate how many IP addresses we will get. Okay, so I will teach you that as well in few minutes. Okay, so before, okay, so now they decided, okay, we are going to stick with the IPv4, but along with that they also decided that there will be some protocols or rules they are going to follow. Okay, so what they divided what they decided is simply there should not be a random usage of IP addresses. Okay, so if we are to use the IPv4, then there will be a protocol. What protocol? The IPv4 addresses will be divided into classes. You're getting it? So what the first decision was, so the IPv4 IP addresses should be divided into classes. So what is this classes? Okay, now let me show you. Second. Right. So this is the representation of the classes. Okay, of course we will not use class D and E, that is, you forget it. So we are going to focus only on class A, B and C. So what is this class A and class B and class B? On what basis they made this calculation? Okay, so I will explain to this in this manner. See, in any IP address there will be two parts. Okay, so for example, if I take this one, in this IP address there is a two elements. So one is the network bit, or the another one is host bit. Okay, so let me write here. So first one is a network bit and the second one is the host bit. It means that you're not going to allocate every bits to the devices. See, you will understand this, okay, when you start working on the IPv4 calculation and assigning the IP address, you will understand it. Okay, so don't panic if this is something new. Okay, so it means that we are not going to assign the entire 32 bits to the devices, right? Because see, there should be some identification, no? Suppose See, for example, if I need to send one postcard or anything from my house to some other place, there should be some identification. Like this is the door number, this is the street number. But in computing world, there won't be something called as the postal address. There will be a IP address. So IP address, the host is identified by the network bit, right? So there are two parts. So coming back to the diagram here, see the network ID or the network bit. So by looking at the network ID, the sending host or the sending server will come to know, oh, to what is my destination. I mean, where I have to send the packets. Okay, of course, these are all networking advanced topics, so we are not going, very deep on networking. But these are all should know the very basics, right? So, like, what is a network ID and all those stuff. So, network ID will tell to where the message has to be sent. So that is identity. If you allocate all as host ID, then what will happen? You will not be able to receive anything. You're you're getting it right. So the network ID will play a role of identifying the device, or it helps in device identification in the network. In simple words, if I have to say, device identification in the network. Okay. Okay. Now coming back to this one. So network bit. So the host identification in the right. I'll write here. And then what is the use of host bit? So this host bit, you will assign it to the devices in your network, isn't it? So in simple words, if I have to say, now we are all having a mobile number portability MNP. So we will not be able to tell by the number series, oh, this belongs to Vodafone or something like that. Okay, so I'm talking about earlier days when there was no mobile number portability, right? If the number is starting from 9845, it is Airtel, it is understood. So something like that. So it is for device notification or device identification it was used. So network bit plays the same role here, isn't it? Say for example, your license plate also, like KA02, KS. So there is something common will be there. KA02 is understood, it belongs to Bangalore Rajajinagar RTO, and the last digit will be different, like MX something, MX 1234. So similarly, there should be some sort of identification. If you simply keep distributing the number, say 1234, so the number series will end. So you will not be able to identify. So for this reason, they divided this into network. So one IP address will have two components, one the network bit and the host bit. Okay, now how much you will have to dedicate to the network bit and how much to the host bit? This was decided based on the classes. Okay, so now I will write the classes here. So classes. Okay, so for example, if you are using class A, that means the just a second. So the network bit was /8, or in other words, only the first 8 bits. So first 8 bits was dedicated to network, and what is the remaining out of 32? If you dedicate 8 bits to the networks, then 32 minus 8, that is 24 bits. So 24 bits to the host. You're getting it? and the CIDR value I will write here. So the CIDR value. So I will explain this. Okay, so the CIDR will be /8. Okay, so the meaning is that this implies that, meaning you are going to mask the first 8 bits in the IP address. You're getting it, right? And along with this, they also made one rule that if you are going to use the class A, then your IP will be from 0 to 120, 0 to 127. Okay, or someone will say 128, doesn't matter. Okay, so 0 to 128. See here, so /8. Okay, someone will say 128 or someone will say 127. Okay, so let us take this example. Let us stick to 127, but 127 is not used by any host, because I will tell you in few minutes. Okay, so 0 to 127 you have to use, and first 8 bits will be dedicated to the network, and the last 3 octets or the remaining 24 bits should be dedicated to the host bit here. Okay, and then the CIDR value will be /8. So this represents that you are going to mask the first 8 bits. So that are, in other words, you are not going to assign it to anyone else. Okay. Now there is also one more meaning to this /8. So /8 means, okay, if you are going to mask the first 8 bits, then what will happen to this value? So this entire value will be 11111. Okay, so the entire value will be 1 1 1 1 1 1 1 1. If all are 1, then how much you will get if you add all these elements? What we discussed before this, if all the places, if you are going to replace by 1, then you have to add. So the value what we are getting here, that is 255. So then what will be a subnet mask? So this is the subnet mask here. So the subnet mask will be 255, because if you add all this, we'll get 255, and the remaining, anyhow we are not going to assign it to network bit, we are going to use it for the host. So this will be 255.0.0.0. So this is your subnet mask. Is it clear? So now we are getting how we get. See, it is not by any random we get this value. If you see here, by looking at this, you will be able to tell which class it will belong to. With few practice, you will be able to tell by few calculation this this subnet mask which class it belongs to. Okay, of course now we are not using class. I mean, we are not following any classes now. We are now following CIDR, that is classless interdomain routing, which we'll be discussing, okay, either today or tomorrow, right? So we are not following any classes now, but before we go into the classless interdomain routing, it is very, very important that we understand this class IPv4 classes. Okay, now coming to the class B. Okay, now I will write class B. Okay, so 128 to 191. Okay, if you are using class B, then your IP range should be between 128 to 191, and you are going to dedicate 16 bits to the network and the 16 bits to the host, and your CIDR will be how much? /16. Then what will be the subnet mask? So 255.255.0.0. Okay, if you get to know this calculation for any one classes, The remaining classes you will be able to calculate very easily without any hiccups. Okay. Then class C, 192 to 223. So they say if you are going to use class C, you are going to use 24 bits for the network and the last 8 bits for the host, and this CIDR will be /24, and this subnet mask will be 255.255.255.0. Is it clear? See, see 255. So this is the range 255.0.0 subnet mask 255.255 and C, and class C. Clear? Now okay, now coming back to this. So 127 we cannot use. Why? Because this is a 127 is a very special address. 127.0.0.1 is a special IP address called as loopback address. So what is the use of loopback address? This will be there in every device for that matter. Okay, if you don't believe me, just go open your command prompt and just type CLS and do ping space localhost or ping 127.0.0.1. So this is the address of your local host, meaning that it is a way of checking whether your Ethernet card is proper or not. Okay, so what is the job of this Ethernet card? It is responsible for connecting to the network. Okay, if Ethernet adapter is not there, then you will not be able to connect to any of the network, whether internal or external. Okay, so this loopback address will come handy while checking the health of the loopback address. So as of now, it is saying it is sent 4 packets, received 4 packets, lost is 0. That means my adapter is perfectly fine. So that is why some people will also mention that it is only till 0 to 126. It is totally valid. So we will change it to 126, and 127 it is for the loopback address. Is it clear? Okay, now still we are not able to get the picture. Okay, so with this we have arrived at the classes, then network bit, host bit. Then how many IP address we can have? Say for example, if I use class A, how many IP addresses I will get? So that calculation is very simple. For example, if you are going to use the CIDR, then simply for the number of IP addresses, what you have to do, number of IP address, you have to just simply subtract, because the IPv4 the maximum bits is 32. Just subtract 8 from 32. The value we'll get is 24. And the IP addresses supports binary, which means 2. So 2 to the power 24. So how many will get? Can anyone quickly calculate what is 2 power 24? Okay, let us calculate here itself. One second. 2 power 24. So 2 power 24 is this. So what is this value? So So 1 crore 67 lakh 77,216 IP addresses. Okay, 1 crore 67 lakh IP addresses. So very huge, right? So 1 crore. So you can spin up 1 crore plus servers in your network if you use this network. Okay. Now let us calculate for class B. So class B, it is also same 32. What is this? So first two bits, first two octets we are going to dedicate for network. So that means it is 16. So 32 minus 16, it will be 16. So per 2 power 16 is equal to 65,536 IP addresses. You can calculate. So 2 power 16 is 65,536 IP addresses. Then the last one, the class C, same way 32 minus 24, which is 8. So what is 2 power 8, which is equal to 256 IP addresses. So the number of IP addresses is based on this calculation. And in the interview, they are going to ask you this question. They are going to tell, they are going to give any, like they'll say some slash 16. They'll ask you to calculate how many IP addresses you may get. Okay. So you should know all this concept before building the cloud infrastructure or anything in cloud computing, because these are very basics and fundamentals. If you learn this, then nothing like it, right? So that is why I am writing everything in an Excel sheet so that it becomes very clear. Okay. Yes. So this is what. Okay. Now then next question. Okay, is before I go ahead, any doubt guys in until here?
In a class A, that range you have set up no 0 to 126.
Hmm.
So how like it refers to what sir? Like ಎಲ್ಲಿ ಅದು ಉಪಯೋಗಿಸ್ತೇವೆ ಅಲ್ಲಿ ಎಲ್ಲಿ ಬರುತ್ತೆ ಅದು 0 to 126 ಮಾತ್ರ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದು ಇಲ್ಲಿ. ಸೊ ಇದು ಫಸ್ಟ್ ಅಂದ್ರೆ ಫಸ್ಟ್ ಆಕ್ಟೇನ್ ಇದ್ರಲ್ಲಿ ಬರುತ್ತಾ ಅದು ಅಥವಾ ಎಲ್ಲಿ?
Octet ಅಂತಲ್ಲ. ಸೊ ಇಟ್ಸ್ ಲೈಕ್ 0 to 126 ಅಂದ್ರೆ ನಿಮ್ದು IP ಅಡ್ರೆಸ್ ರೇಂಜ್ ಅದ್ರಲ್ಲಿ ಇರುತ್ತೆ ಅಂತ ಅರ್ಥ. ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 10 series ಅಂತ ಅರ್ಥ. ಟೋಟಲ್ ಅಂತಲ್ಲ. Your network will start from like this. So 10.0.0.0 ಆ ತರ.
Okay. So if my IP address is starting from 129, it is a class B, right? So like that, sir.
Yeah, correct.
Okay, sir.
Okay, so that is before. ಇದೆಲ್ಲ ಆಗಿದ್ದು ಬಿಫೋರ್ ಕ್ಲಾಸ್ಲೆಸ್ ಇಂಟರ್ ಡೊಮೈನ್ routing. Okay, when there was a restriction, because if you are using this number, you have to follow this restriction. Now there is no restriction at all. Okay, but you should know this in order to understand the classless inter-domain routing. Otherwise, if I directly jump into classless inter-domain routing, you will not understand anything at all. So that is why I start with the basics. Okay, so this number will tell that your IP will start, in simple words, it is going to start with this number. That's it, nothing else. Clear? Anybody else? Okay, so let us proceed further then. Right. Okay, now as you can see here, if you go with the class A, then you are having an advantage. If you go with the class C, you are having a very less advantage, because only 256 IP addresses, isn't it? So they felt sort of restrictions, because if you use this, then you will have a lot of IP addresses, but you are not going to use them anyway, right? And there was also a necessity to divide the bigger network into small networks. Okay, so this is very important concept. Please listen carefully. See, there was two restrictions. One was, see, if you stick with the classes, you are going to get a big one or a small one or intermediate. So first one you have to choose. Then along with that, there will be a subnet mask. Okay, subnet mask in the sense, it will just tell you that these hosts you cannot assign to the host. So dividing, so there was also a necessity for the organization to divide their network. Like for example, they will not how do we put it in a simple way? Okay, suppose in a cupboard, so we'll not dump everything in a one compartment, right? So there will be several compartments. So one for bed sheets, something like that, for shirts, something other items. Okay, so we will divide it in a very as per our requirement. So how much is our requirement for the space? So we will divide it into that size, isn't it? So that is while they were facing these restrictions, so they came into the concept of CIDR, that is classless inter-domain routing. Okay, before that, let us understand that. Okay, so why? A minute. Mhm. Okay. Yeah. Can this is the one here? Okay. So as you can see, this is also a very good example. See, now this is a one big organization. Okay. Now, if you think that, okay, as per the discussion, what is which class this belongs to? This belongs to class A, correct? So class A means 1 crore 67 lakhs IP addresses. So rather than having the entire 1 crore 67 lakhs as a one big network, they used to divide it into smaller network like this, so that one small sub network they will assign to one team, another one to the another team. So that is why subnetting is very, very important. Okay, so there is another diagram here. So as you can see, they are all belong to the same network. So if it means, see, 10.0.0.0/24, these are also same. So they all belong to the same network. So how we can tell that because of this CIDR value. So the CIDR value is all is same for all the three devices shown in the diagram here. Is it clear? So that is why rather than having everything as a single big chunk, so it was becoming difficult to manage the routing table and everything. Okay, so then what is routing table? See, routing table are very important to route the packets from source to the destination or from one device to the another. Okay, any device will accept traffic based on the information. Okay, think that routing table is a information by which the devices accept or sends traffic. Okay, in simple words. Okay, so that is why there was a need of subnetting, right? So subnetting is nothing but dividing the bigger network into smaller network, isn't it? Okay, so now let us understand how we can divide the network. Okay, so now let us go back to the Excel. Okay, so how we can divide? Suppose, okay, I will take the smallest network first, otherwise you will get confused how we can divide. Okay, now, okay, before we divide, now I am telling that 2 power 8 is equal to 256. So how the IP numbering will differ? I mean, how will the IP number or the IP address will start? So it will start from 192.0.0.0. You can keep it. See, anyhow, as per the class C, the first 3 octets you are not going to assign anything. So you can keep anything, any number for that matter. So I'm going to name it as 128 dot say 100 dot 23 or 101. So let us make it some fancy. Then slash 24. So what does this mean? Now I am making this as a unique as a my network ID. So this is my network ID. Say Mithun network, or let me put it as a say xyz.com. Clear? Now it means, so my first IP will start from 192.100.101.0 to 192.101.255. So this is the range of your network. Why? Because only 256. Now you start counting 192.100.10.0 to 192.100.101.255. How many will come? Or else you just drag until 256 are done. See what is happening here. So this is how it will be allocated. So 251, 253 and 255. See, so these many IP addresses you can associate. You're getting this? So it will start from there. This is your first one and this is your last one. So this is represented here. So these many servers you can launch, and you can maximum launch up to 250. Is it clear? So why then, if you are happy with this structure, then what will happen if you are choosing class C? Then your entire devices will be like this. So there won't be any subnetting or something like that. Okay, your network is this. and whatever I have showing in the gray gray portion, right? So that is your IP address. This is your network ID and this is your host. That's it, finish. But there is no, will it look nice? I agree it is 256 entry, but is it looking nice? Like all them you are grouped together. We need something like this, right? So this is having this one, there is some bifurcation should be there, isn't it? Only then it will look nice. Like this, a grouping should be there. Hmm? Clear? So this is the thing. See here. So subnetting is the dividing the big network into small chunks. So if I have to show it in Excel, it is a way of, so like, okay, this much. I'm just giving an example. So okay, this much to team green. Okay, then this much to, I'm just picking up random. Okay, so there is a formula to do that. So this is for team orange, like this. So in that way, if you divide, then it becomes very easy to manage, right? So that is why there was a need for subnetting, and also there was restriction with the the number range. You have to select this. Then there is a restriction. Okay. So finally, they decided that let us not follow these classes anymore. We are not going to follow these classes anymore. It means that you can pick classless inter-domain routing was introduced to solve this problem. Okay. So why CADR? To solve the problem. Okay. So there was a need or requirement to bypass these class restrictions or bypass the restriction imposed by the classes. You're getting it? So, and this was very needed because this made the networking much more simpler and made very easy. Whatever, in other words, it made easy for network engineers to manage their infrastructure very easily. Okay, so with subnets it becomes very easy to manage your infrastructure. Okay, you will observe or you will also feel when you start building in your own accounts. Okay, now with classless inter-domain routing, all the all the restrictions were lifted. What is that restriction? Is there is no range. You can use any range for your wish, and you can pick 192 and you can use this subnet, no issues. You can use this one and you can use this one, no issues. It is up to you. And there was another breakthrough. The main important is they were not strict to only the first 8 and the first second, the first 2 or the first 3. What they did is you could have also borrowed from the, say for example, now yes, look at this diagram. Let me write it here. So what we explained here, that if you take this IP address and as per class A, so 172, let me write it in the different color. So we were told that okay, we can use, okay, this means this first octet is for only network and the third and the remaining 3 octets for host. But with classless inter-domain routing, it is not like that. You could use 2, 3, however, how many bits you want from the second octet also. So in the sense, rather than 8, you can also use /10, /12 like that. Okay. Or in other words, in between 16 and /24, you can use any number. /17, /18, /19, /20, /21. So based on that, we will get different amount of IP addresses. Okay, so what were the restrictions? The first one is with CIDR. Okay, no restrictions on number ranges. Then second one is no restrictions on network bits. No network, no restrictions at all. You can have any n number of thing. Okay, as per your need. Okay, so that means you can have /any value you could desire. Clear? Now with this you can divide the big network into smaller networks. So how we can divide that then? Okay, so take this example itself. If you have to divide it into 2 parts, so then what we have to do? So the shortest trick is just change this 24 to 25. So let me show you. First I will write here. Okay, let me write here. Okay, so this is my network. Okay, if I have to divide it into 2 parts, so how we are going to divide? So the part 1 or the subnet 1, and this is subnet 2. So how we are going to divide? So subnet 1 will be 192.100.101.0/25. Okay, then calculate how many IP address will get. Simple. So 32 minus 25 equal to how much? 2 to the power 7, which means 128 IP address. Correct? Isn't it? Yes or no? 128 IP address. So that is the reason I took this example, because it becomes easy for you to analyze things. So 128. Okay, then totally fine. So start from here. So 128 means 101.0.02 to here. So this is belongs to team green. 128, isn't it? So 0 to 127, it becomes 128 IP address. And the remaining already anyhow from 128 to here, team yellow, or you can take, okay, team orange. So this from here to here will be subnet. So then how we write? So my subnet 2 will be 192.100.128/25. Is it clear? How I got this number? Very simple. From where it is starting? 192.100.101.128. Simple. Here I got the number. So this is my subnet 1 and this is my subnet 2. So both now has a 128 IP address. So you can check for yourself. Now let me show you. So how many are there? 128. So this similarly, this one will also have a, see, 128 IP address. Clear? Okay, so I'm going to stop here today. Otherwise, you may feel it will be complex. So any doubt, guys, before I stop?
Sir,
No, sir.
Hello?
that CIDR, you said no, sir. When we get into CIDR, it's is it included in the IPv4 format?
Yeah,
Because
yeah,
you
yeah.
said no restrictions on a network bits. If you are like cutting the bits on 12 or something like that, so
Yeah, you can use. So with the classless inter-domain routing, you can use any number. And the subnet mask will also change.
okay.
Is it clear?
Yes, Mithun.
Okay, anybody else? Okay,
No, Mithun.
so guys, yeah, go ahead. Somebody was saying something.
No, got it, got it. No, no, I said we got it. I got it.
Okay, okay. Okay, so tomorrow again we are going to continue with this. Further, we are going to take up another big examples, and then we will start calculating the subnets. Okay, so how we are going to divide into 2, 4, 6. So like that we are going to discuss. Okay, so yeah, anybody? I hear something, someone saying something. Okay, so I'm going to share this with you as well. Okay, so if there are no doubts, then that's it. So I'm going to stop the recording.